A tiny speck in the vastness of space suddenly blips into our view. An interstellar visitor so strange, it makes us question everything we thought we knew about the universe. Imagine an object from beyond our solar system, hurtling through the darkness at unimaginable speeds, carrying secrets that could reshape our understanding of physics and existence itself. The story of 3I/Atlas is more than just a cosmic mystery. It's a mirror that reflects how fragile, how fleeting our place in the universe truly is. As we peer into the unknown, what if this visitor holds clues not just to distant worlds, but to the delicate thread that connects us all in this cosmic dance? Stay with me, because uncovering its secrets might just change how we see ourselves forever. The discovery of 3I/Atlas. In the vast silence of space, a small, unassuming object was caught on the edge of human observation, shimmering briefly against the backdrop of stars and dark nebulae. Its designation, 3I/Atlas, initially bore the hallmarks of a typical comet or asteroid, but as astronomers directed increasingly focused telescopes its way, something about it defied expectations. Unlike many interstellar visitors, 3I/Atlas appeared to have unusual velocity and a trajectory that suggested it wasn't bound by the gravitational pull of our sun or any nearby planetary system. It was hurtling through an alien guest with no apparent origin within known star systems. When its position and movement were charted, it suddenly became clear this was no ordinary cosmic traveler. It was an interstellar object, a visitor from a distant, unknown star system, and yet it seemed almost too perfect for such a visitor. The discovery was dramatic, unfolding in a way that felt like peeling back layers of space-time itself. Telescopes from across the globe caught glimpses of its elongated shape, a shape that hinted at a rocky core covered in a thin, possibly icy crust. Its speed, far faster than typical solar system objects, pointed toward an origin outside our local stellar neighborhood. Astronomers were quick to recognize that, based on its acceleration and trajectory, 3I/Atlas had to have come from a stellar system far beyond our reach, screaming through the cosmos at a velocity that would shatter any assumptions about its nature. Its path was a hyperbolic arc, like a cosmic arrow shot from a distant star. And yet, there was something uncannily deliberate about its shape and movement, fueling debates about whether it was an asteroid or something more enigmatic. Almost overnight, 3I/Atlas shifted from being just another distant rock to the subject of intense scientific curiosity, sparking a flurry of questions and speculations. How long had it been traveling through the galaxy before passing through our solar system? What kind of star system did it come from? Was it a natural object, or did it bear signs of some sort of artificial crafting, some pattern or detail that might point to an intelligent origin? In that brief window of discovery, the object seemed to stretch the limits of what we thought was possible in our universe. An interstellar freight, flying faster than our technology could ever hope to track, with the aura of mystery fueling both wonder and unease. What made the discovery even more profound was the realization that such objects have likely been traveling through space for millions, perhaps billions of years, crossing vast cosmic distances, silent witnesses to the universe's grand narrative. Yet here it was, suddenly within reach, almost teasing us with its secrets. The fragility of our existence suddenly became sharper in focus, a reminder that amidst the enormity of space, solitary visitors like 3I/Atlas can appear and vanish, illustrating how fragile and fleeting our moment of awareness truly is. Humanity's gaze, intense and eager, now turned outward, caught on a visitor that might not belong to any known universe, forcing us to confront the vast, enigmatic nature of the cosmos and our tiny, delicate place within it. Unusual trajectory and velocity. The path of 3I/Atlas defies what scientists typically expect from objects wandering through our solar system. Most interplanetary travelers slowly drift in with trajectories that can be predicted by gravitational nudges from planets and the sun. But Atlas arrived on a course that seemed more like a missile, steering unexpectedly and with unanticipated speed. Its trajectory was hyperbolic, meaning it was not bound to the sun, but instead just passing through, hurtling at an astonishing velocity. To put that into perspective, most small objects or comets that enter our neighborhood tend to slow down or alter course as they approach the sun, influenced by gravitational pulls and solar radiation. Atlas, however, zipped past in such a way that it barely gave the solar system a moment to react, almost like a cosmic bolt slicing through space. What makes Atlas's velocity remarkable is how it challenges expectations based on what we know about interstellar visitors. It arrived at a speed estimated to be around 26 kilometers per second relative to the sun, a rapid departure from the norm for known objects from other star systems. Its speed, combined with its trajectory, suggests it originated from somewhere far beyond our local stellar neighborhood, possibly from a star system entirely outside our own galaxy. In the vast emptiness of space, objects like this are expected to have velocities aligned somewhat with the gravitational dance of stars and planets nearby, but Atlas's velocity hints at an origin story that's not so tidy. Its path seems almost to have been artificially scrambled or influenced by forces we've yet to fully understand, like a cosmic game of pinball. At the core of this mystery is the fact that an object from outside our solar system shouldn't be moving in such an unusual way, at such an incredible speed, and along such an irregular trajectory. Think of it like a puzzle piece that doesn't quite fit with the picture we have of our local cosmic environment. Its hyperbolic orbit suggests it was gravitationally slingshot around something bigger or perhaps even ejected from a star system in a catastrophic event, such as a supernova or planetary collision. Yet, the velocity was so powerful that it seemed almost like a probe, an alien craft, or at least something that has been pushed to the very edges of natural physics as we know them. This unpredictability fuels a deep sense of wonder and unease, questioning how many other travelers like Atlas might be out there, rushing through the darkness with stories we have yet to decipher. As the object continues on its journey out of our cosmic neighborhood, it leaves behind a trail of questions about our understanding of physics and the universe's boundaries. Its velocity and trajectory strain the limits of our current models, almost as if the universe itself is testing us. To think that something so fast, orbiting so unexpectedly, could be a mere visitor or a fragment of a long-lost alien technology makes our place in the cosmos seem fragile, almost accidental. Maybe, in its fleeting visit, Atlas whispers that the universe is stranger, more chaotic, and more beautiful than we can imagine, reminding us we are just tiny, fragile beings amid incomprehensible vastness. Composition and physical characteristics. Fragmented and irregular, 3I/Atlas's surface hints at a tumultuous past buried beneath layers of cosmic dust and debris. Its overall shape deviates from the smooth, rounded spheres we often associate with planets or moons. Instead, it looks like a battered shard, jagged in places and flattened in others, reminiscent of a cosmic puzzle piece that somehow got lost in the vastness of space. Studying its external structure reveals a complex mosaic of ridges, craters, and uneven terrains, evidence of fierce impacts and unrelenting space weathering. These surface features suggest a history marked by collisions and close encounters with other celestial objects, eroding and reshaping its form over eons. Diving into its composition feels like unlocking the secrets of the universe's most primitive materials. The spectral analysis shows a surprising mix: a dark, carbon-rich crust overlaying a more metallic core, with hints of silicates and possibly volatile compounds trapped within. Its surface appears to be coated in a layer of organic molecules, complex carbon chains that could shed light on prebiotic chemistry. And this dark layer acts like a cosmic shield, absorbing sunlight and limiting thermal fluctuations. Beneath that, the reflecting metals indicate areas where the asteroid's interior has been exposed by past impacts or subsurface voids. This mixture of organics, metals, and silicates points to a primitive, unaltered chunk of the early solar system, a relic of the primordial chaos that shaped our planetary neighborhood. Physical measurements reveal an object that defies simple classification. Its dimensions stretch roughly a few hundred meters across, but it's far from symmetrical. The object's density speaks volumes about its internal makeup. It's low enough to suggest a porous, rubble pile structure, held together loosely by gravity rather than solid rock. Imagine a loosely packed cluster of pebbles clinging together in space, with voids and gaps coursing through its interior. This porous architecture can be seen as a kind of natural spaceship, a fragile assemblage of materials that could fragment if subjected to enough stress. Simultaneously, certain regions appear more compact, hinting at zones of sedimentary deposits or cemented rock, which might protect parts of the asteroid from disintegration during future encounters. All these details point not merely to a rock hurtling through space, but to a fragile, complex entity, one that reflects the chaos and beauty of the universe itself. Its composition and physical makeup evoke a sense of vulnerability, like a delicate glass sculpture floating amidst the infinite darkness. Humanity's encounter with such a visitor feels almost surreal, a reminder of how tenuous our grasp on stability truly is in this vast, unpredictable cosmos. In capturing its essence, we are confronted with our own tiny, precarious foothold, and perhaps with a quiet humbling that echoes through our collective consciousness. Implications for interstellar object theories. The discovery of 3IATLAS shattered many preconceived notions about what interstellar objects could look like and where they might originate. Unlike other interlopers, such as 1I/Oumuamua, which exhibited strange non-gravitational acceleration suggestive of cometary activity, Atlas's physical properties challenged the standard models. Its more elongated shape and unusual reflectivity hinted at a history far more complex than simple debris ejected from another star system. This has ripple effects on the broader theories that scientists hold about the population of interstellar objects. The traditional assumption that such objects would be mostly icy, comet-like chunks or rocky asteroids is now called into question. Instead, there could be a wider array of material compositions and physical kinds that resist easy classification. The implications stretch into how we understand the processes that generate these objects in their home stellar systems. Standard models posit that planetary collisions and gravitational nudges fling small bodies into interstellar space. But with objects like 3I/Atlas, evidence begins to suggest that some interstellar visitors might not be mere debris from planetary formation, but could represent a more diverse set of origins. They may include fragments of asteroid-like bodies that have undergone extensive space weathering, or even objects with unusual internal structures that survive ejection events better than previously thought. This diversity would mean planetary systems elsewhere could produce a broader spectrum of small objects. But our theories for how these bodies are formed, ejected, and survive interstellar travel need refinement. Beyond that, the presence of objects like Atlas challenges the frequency estimates of interstellar visitors. If these bodies are more varied, and some are more resilient than expected, then perhaps the processes that send them hurtling through space happen more often or via different mechanisms than the classical models suggest. The shock comes partly from the realization that ejection could occur through forces we hadn't fully appreciated, such as intense volcanic activity, tidal disruptions near massive planets, or even artificial origins from extraterrestrial technologies, if one entertains broader speculations. This pushes scientists to revisit their assumptions, question whether our star-centric models adequately encapsulate the chaos of planetary systems in the galaxy, and consider an entirely wider universe of possibilities. In the end, these revelations strike at the core of humanity's quest to understand its place among the stars. If objects like 3I/Atlas are indeed more diverse, more resilient, and more enigmatic than previously thought, then the universe is a far more unpredictable place. It reminds us that our current knowledge is like a fragile sandcastle, easy to topple by the gentle wave of a new discovery. We stand on the shore, staring into the vast depths of space, knowing that even the most seemingly solid foundations of our cosmic understanding can crumble with a single, unexpected revelation. It's a humbling glimpse into our fragile grasp on the universe, an echo of how little we truly know and how much remains just beyond our perceptual horizon. Debates and controversies surrounding its origin. When scientists first analyzed the trajectory of 3I/Atlas, they were struck by its sudden appearance and unusual velocity. Unlike most objects in our solar system, which tend to follow predictable orbits shaped by gravity and the sun's influence, Atlas seemed to have arrived from a direction and speed that defied easy explanation. Some researchers suggested it might be an interstellar object, simply passing through, but others considered the possibility that it could have originated elsewhere, perhaps from a distant star system or even an entirely different cosmic neighborhood. The key debate centers on whether its physical characteristics and motion genuinely point to an interstellar origin, or if there's an overlooked local explanation. A major point of contention is the object's shape and brightness variations. Observations indicated that Atlas was highly irregular, with an elongated form that might resemble a shard or fragment rather than a natural asteroid from within our solar system. Such a shape hints at an origin in a violent cosmic event, like a collision in a distant star system, which could produce fragments ejected into space. Critics argue that what looks like an interstellar visitor could still be a solar system visitor from the Oort cloud or Kuiper belt, some distant, icy relic that was perturbed inward for reasons we don't fully understand. This skepticism fuels ongoing debates as scientists weigh the likelihood of an interstellar origin against more mundane explanations rooted in our local cosmic backyard. Visual metaphors help us grasp the controversy. Think of a meteor streaking across the night sky, but only seen briefly and with few clear details. The masquerade of an exotic, far-flung origin masks the possibility it is akin to a pebble knocked loose from within our own cosmic garden, an object that simply took a bizarre, indirect path towards us. The question of whether Atlas is a cosmic stranger or a local oddity remains unresolved, each hypothesis with its own compelling narrative backed by different sets of data. Some argue that the unusual velocity and trajectory are best explained by it being an interstellar visitor, akin to a cosmic alien spacecraft lost from its home star, whispering tales of distant worlds. Others suggest it is a rare, ejected fragment from our own solar system, caught in an unexpected cosmic twist and never truly foreign at all. Then, there are more speculative theories, some bordering on the fringe, proposals that such objects might be deliberate probes or even remnants of alien technology. These ideas are controversial because they challenge conventional science, but also stir imagination about the possibilities that exist beyond our understanding. The core uncertainty remains. Can we definitively trace the object's path back to a star beyond our solar system? Or are we simply reading cosmic codes that are too encrypted for our current tools? For now, Atlas remains a mystery wrapped in cosmic riddles, a fragile reminder of humanity's limited reach into the vast, unknowable universe. It's as if we stand on the shore, gazing at the endless ocean of stars, trying to decipher whether a solitary flicker is a message or just another drop of cosmic rain. Such moments expose how delicate our grasp on the universe truly is, and how vulnerable we remain, small and curious, in the face of the cosmos's vast, whispering silence. Usnavnori, Rusdil 6. In the ongoing saga of interstellar objects visiting our solar system, one of the most perplexing puzzles is how some bodies like 3I/Atlas seem to arrive seemingly out of nowhere, defying the conventional understanding of how objects drift through space. The core mystery hinges on the object's trajectory and origin. Unlike debris expelled from comets within our solar neighborhood, these interlopers come from distant regions of the galaxy, traveling at velocities that suggest they were ejected long before our solar system formed. Their paths often cut sharply across the solar system, exhibiting hyperbolic trajectories that indicate they are not gravitationally bound to the sun in the way typical asteroids or comets are. This alone raises fundamental questions. How did such a body end up on this exact escape route? Visualize space as a vast, invisible ocean with countless ships, some built within our own port, others from far-off lands, rushing through the darkness. Most ships follow predictable currents, but occasionally, a vessel from another port stumbles into our waters by accident. That's what makes objects like 3IATLAS so startling. Their journeys look more like stray comets drifting from distant star systems than objects created long ago in the solar system's neighborhood. What amplifies this sense of wonder is the fact that during its passage, astronomers saw signs of activity, cometary outgassing, and yet there was nothing to suggest a typical comet origin. The object appeared more like a rocky asteroid, yet with some comet-like traits. It seemed to be a strange hybrid, a foreign artifact, perhaps ejected from a planet-forming process or collision in a faraway star system. The idea that such objects could actually be visitors from elsewhere implies a universe filled with these cosmic messengers, each carrying secrets about their parent star systems. Their presence feels almost like a cosmic anomaly, an uninvited guest dropping into our neighborhood, leaving behind questions that challenge our understanding of planetary formation and ejection mechanisms. Physics tells us that objects can be flung out of their native systems through gravitational interactions, close encounters with massive planets, or toing and froing through star clusters. But the sheer speed and trajectory of 3I/Atlas suggest it was expelled with tremendous force, perhaps by a giant planet's gravitational shove, launched into interstellar space with enough velocity to escape the gravitational pull of its home system. From afar, these objects might seem insignificant, but their journeys reveal history, violence, and chaos from worlds beyond our comprehension. And yet, for all its scientific intrigue, the presence of 3I/Atlas strikes a deeper chord. It confronts humanity's fragile sense of safety in the vast, cold silence of space. This fleeting visitor underscores how delicate our gravitational bubble is, how easily the cosmos, with all its grandeur, can send a stranger hurtling through the void. It's a reminder that while our planet is a pocket of life amid the darkness, it remains vulnerable and exposed to external forces and unknown visitors. Each discovery of one of these interstellar wanderers breathes new wonder and a slight, unsettling realization. In cosmic terms, we are but a tiny island amid a universe teeming with unknowns, and perhaps fragile enough to be touched by strangers from the far reaches of the galaxy. As we turn away from the mysterious shadow of 3I/Atlas, what lingers is a profound reminder that the universe still hides secrets that challenge everything we think we know. This interstellar visitor, seemingly impossible, suggests that the cosmos is full of surprises, objects that defy our most basic understanding of physics, like a ship out of a sci-fi story, suddenly made real. Imagine crossing the vast emptiness of space, like a needle piercing through a cosmic fabric, and stumbling upon something that shouldn't exist, yet does. It's as if the universe is whispering, "There's so much more to discover." This journey through the strange physics of 3I/Atlas helps us see our place in the grand scheme, not as isolated beings, but as part of a vast, mysterious universe constantly eager to surprise us. It's a reminder of how fragile and precious life is, floating on this tiny sphere of water and air in an incomprehensibly vast cosmos. Our curiosity, our willingness to peer into the unknown, these are the sparks that keep us alive and pushing forward, even when the answers seem just out of reach. So, keep your eyes to the stars and your mind open. There's more to uncover, more to understand, and countless wonders waiting just beyond our current horizon. If this story has sparked your curiosity, stay with us. There's much more to explore, more mysteries to unravel, and more truths about our universe that will leave you both humbled and inspired. The universe is a fragile, beautiful place, and it's up to us to cherish and protect the pursuit of its secrets.